Yeah, I think it's good point in time to start now. So, good morning, ladies and gentlemen, dear colleagues. I would like to say also dear friends. It's an honor to me to open the session or the first event of our Green Tuesdays from R2Gas. And this is focused on syngas generation and utilization. The procedure is like this, that I will do now a short presentation and will be supported by Christian Eichernick, who also will add some details on different plants and different informations we had there. And so I would like you to note down your questions, and you can place them already in the chat during the presentation, and we will pick them up at the end of the presentation. And at the end of the presentation, also the discussion will take place as we wrote in the invitation. The idea was to have a rather short and to the point discussion about latest developments. And it's like if you would like to meet somebody during the coffee break. And so for this reason, it will be a relaxed atmosphere during the discussion. And so the first part is the presentation. I've divided the presentation into four main sections, or let's say three, because the first section is about the potential, the biomass potential in Austria. The second one is about the all the plants and technologies and some promising projects. And the third one is about barriers or the outlook and conclusions. What does it mean for syngas and utilization? And I won't go into detail of each of the slides, because it was also the idea to give you repository or some presentation where you can have a look on it afterwards if you need to look for specific information. And for this reason, I would just like to give you a short overview about all the main informations. And in that sense, I've presented already the result about the biomass potential in Austria, the total potential in Austria, as you can see here in this row. And this has been picked from a real recent study, because that's also one aim of our Green Tuesdays, to provide information that's to the point, because there's so much discussions going on about biomass potential, and there are people out there like the Austrian Biomass Association or Bioenergy and Sustainable Technologies who are doing this evaluation of potentials, and it just need to be summarized. And politicians are discussing if there's sufficient potential available, and there are people who are trained to determine the potential, like the managing director of the Austrian Biomass Association. And if these people are summarizing figures, we don't have any better ones in Austria. And the result of the latest study of the Austrian Biomass Association was that we have around 200 petajoule of additional potential in the year 2045 in Austria. And in order to make a really serious assessment, they've done three scenarios. One scenario was with a higher agricultural amount of biomass. The other one was with the highest potential, and the same was with the industry and others, wood forestry. So it was just a difference in between the different sectors. And the result was all the same, that it's around 200 petajoule a year. And what hasn't been shown in the study is the maximum amount. Is just the sum of this potential. It's up to 300 petajoule in the year 2045. And so this means the total available biomass in Austria is about 450 petajoule or 538, and the consumption at the moment is 250. Or the utilization, what we have. So if you know that the primary energy consumption also is 1,100 petajoule, then it's clear that just with bioenergy alone, we can produce half of the energy we need in Austria, at least, because we can also acquire additional potential. And so the reference is here. The following slides are just details. This means the sectors are shown here. This means wood and forestry, industry and others, agricultural biomass, liquid biofuels, and the detailed estimation you can see on the following slides. There's 3 slides, and the conclusion is that we can at least provide 20% of additional bioenergy in Austria. And this would mean, if you're talking about the gasification, because this is the topic we have today, between 140 and 200 plants of syngas conversion plants are required in Austria. And from my point of view, that's feasible. I took into consideration 50 megawatt plants when drawing up the number here, about the 200 plants which can be built in Austria. And this is the first section about the potential. The next section is about the technology. Technology, interesting projects. And at the beginning, I would like to show you a slide in order to make you understand how it works to implement technologies. It's always about R&D. So this means if you're talking about a very simple example, like the synthetic natural gas plant that has been mainly developed also in Güssing. Then we had a test rig at the beginning on technology readiness level of 4. The next was to build a demo plant in Güssing, technology readiness level on 7, and the industrial plant was then state of the art. This means technology readiness level on 9. Which has been installed in Göteborg. And if you're talking about the schedule, then it's always that it takes, let's say, 10 to 15 years. Once the process is invented in the laboratory or the first assessment has been done, until the final demonstration plant is built. And in the case of this process chain from Güssing to Göteborg, we had rather good luck because it was financed. Usually, if you're talking about other technologies, then there are ideas which are at least as good as the SMG idea, but we have to apply 3 or 4 times in horizon, and then there's a delay of 4 or 5 years for each project stage. So this means if you're relying on the financing as it is or available in Europe, then it's not 10 years, usually it's 20 years to make a technology ready. As I said, my presentation was designed as some kind of repository. So one information that you have here is a summary about all the gasification projects, and the presentation is also like this, that you just can click on the link there. You'll receive the PDF afterwards, and or a link where you can download the PDF. And then if you just click on the presentation where you see a link, then you come to, for instance, the gasification project reports from task 33, or what best have done, the overview about gasification plants with detailed information about each plant. Just click on the link afterwards and then have a look on the information available there. Next important main pillar or cornerstone of our discussion should be the readiness level. So this means how many plants are installed on the market. And if you're talking about the gasification plants I mentioned before about Dual-Fluidized Bed, we have some working references, but it's not too much. So, and for this reason, I have also included a list about fixed bed gasifiers. This means it's not syngas production, because these are air-blown gasifiers. But as you can see here, there are a lot of manufacturers for this technology, and these manufacturers provide reliable technologies, and they have installed hundreds of plants. And this was the reason why I included this one, because there's already an industry existing, and what we are talking about now, that we need the industry also in the field of dual-fluidized bed gasification. Now let's come to the detailed technologies. As I mentioned before, Christian Eichernick is already in the meeting, and he will just extend something. So if I forget some information, or if you find that there's something useful missing for the audience or for our colleagues, and please make a break and add this information, Christian. One plant which is mentionable was the Agnium plant. So because the idea was interesting, it was about the heat pipes which transfer the heat into the gasification zone, and it was a lithium-based heat pipe where the heat has been collected in the combustion zone, has been introduced to the gasification zone, and it's some time gone until this plant has been installed. And so this reason my idea was also to make a summary about the previous technologies and the still existing technologies. Of course, it wasn't possible to include every plant. For instance, the new plant of Repotec, Kristen Iconic in Japan, and also details about the R2Gas project hasn't been included there. But many different other plants, like these plants, which you certainly maybe know, because you are on our mailing list, and for this reason we already provide information about these things. Latest development in the field of dual-fluidized bed technology has been the plant in Wien-Simmering from Bioenergy and Sustainable Technologies. So it has been built by SMS Simag, and for my personal part, it's a very sad development, because the site in Güssing has been shut down and all the equipment has been moved to Wien-Simmering. But it was a good step for the technology, because what has been demonstrated on at a small site in Burgenland for just 4,000 inhabitants is now demonstrated in Vienna. And I think it's a perfect site there, because the wastewater treatment plant is included there, also the AD plant. And BEST is now really speeding up with demonstrating technologies like Fischer-Tropsch. And we had a common EU project, the Horizon project, where we installed the first continuous aqueous phase reforming reactor all over the world in Wien-Simmering, and we made a successful demonstration of the entire process chain, where we combined the dry route from the gasification with the wet route, where we can process nearly everything via hydrothermal liquefaction and a combination with aqueous phase reforming. So for this reason, research is expanding a lot in this kind of field. Another example, which is maybe not too much known, it's listed in the publications of the Austrian Biomass Association, but I don't know if everybody knows, is the plant in Nongbuur. This was also from one of our close cooperation partners from Güssing Renewable Energy, and it was a successful demonstration in Thailand of electric or a combined heat and power plant. Güssing is maybe known. As I said, it was a very good research site. So infrastructure in Vienna isn't still that good as it has been in Güssing for carrying out the experiments, but yeah, it's not worth to complain, because this time is gone. And what needs to be mentioned is that it was a successful project, because sometimes people are asking me if it's in operation or not, and it's not in operation, of course, because it used to be in operation as scheduled. This means very smooth startup, then all the time more than 7,000 hours of operation a year, and finally the shutdown after the border conditions changed. This means there has been a feed-in tariff granted, and then it wasn't granted anymore. It's also rather kind of complicated topic how it was some kind of political decision not to extend it, but it doesn't matter, because it has been paid back completely. There has been a lot of research projects being carried out. There has been more than 100,000 hours of operation on the gas engine. So for this reason, it was a demonstration plant, and it has been operated like a commercial plant or an industrial plant. So for this reason, it's a rather good success, the project in Güssing. The same is with Oberwart. Oberwart is now currently converted by the owner into a Syngas production plant for the cement industry. So for this reason, I would like to say this is also a success. And so what's also important, that they are aiming now for utilizing waste. And so for this reason, this was a fine project. There has been another plant built in Villach. The Villach plant has been bought by the same owner of the Overwart plant and was also a successful project. The same has been with Ulm. So the final result wasn't also that, sparkling, I would like to say, because I think, Christian, at the end, it used to be something like that they haven't been focusing on gasification anymore. It was some kind of converting into maximum heat and electricity production.
Yes, the main problem of the Ulm plant was that the feedstock was not really available in the region, so it became more and more expensive. And at a certain point, it was difficult to have an economic basis for the further operation of the plant.
Yeah, it's sad, because the operators have been very, very good, and they also funded a company in order to promote the gasification technology. And yeah, there was the shortage on the feedstock, and but they tried also to use the biogenic residues, and then it was too expensive at the end.
Yes.
Then a rather interesting project of West Biofuels. I think there's at the moment there's nobody in our meeting from West Biofuels, because they said they will watch the video afterwards. But there is a rather good cooperation with West Biofuels within the past 15 years or something. It's also based between the collaboration between the universities. This means the University of San Diego and the Vienna University of Technology. And what they've done was to install a dual-fluidized bed reactor already in 2007. And then there was also some kind of know-how transfer. This was the good thing about the open innovation strategy. And I think this is also a good point to thank Professor Hofbauer, that he has published so many things, and this is a main basis why this technology can be now commercialized, because there has been a lot of details being solved and published, and this helped all the people which have been included in this research. And so situation in California is some kind of different, because the agricultural industry is different, and they're using almond shells for instance. But it's going on a lot there, and what they're doing now is starting a new project, but it's too early to mention it here. The Gaia project, maybe you would like to say a few words, Christian, about the Gaia project?
Yes, the Gaia was a 500 kilowatts research gasification plant for Engie in France, situated next to Lyon. And it was commissioned, as you can read here, in 2017. There is no commercial operation scheduled, so this information is wrong. It is built as a research plant, and that's the only purpose. It is operated in campaigns, and it is equipped so that different kinds of biomass and other feedstock can be processed into the plant. It has several features to further optimize the gasification process, and it has a complete gas cleaning and an SNG synthesis step. So it is equipped to produce between 200 and 300 kilowatts of SNG as well.
And my information is not right, because I'm talking about SNG 0.1 ton per hour. So this means it's 0.2 tons per hour.
Yeah.
Yeah, sorry, I just picked it from the internet. It's sometimes it's hard to find the information, and I haven't been involved at all into the Gaia project. I just heard about it. Yeah, and then some other plants where I've been facing the same situation. to hardly find some information. And in most of the plants, I don't know the active people there, and I haven't been there. And for this reason, my information is mainly limited to the information I took from the IAA task report and also from the internet. One of these plants has been the biofuel demo plant, and they claim to have the startup in 2021, and they are aiming mainly for sustainable aviation fuels. My point of view, it's a rather potent consortium, and so it's just the technology itself. I would like to say it's some conventional technology. This means the Fischer-Tropsch reactor and the combination with the gasification afterwards, the fuel production. Then I found the Falcon bioenergy plant or the Inentec Sierra biofuels. As I said at the beginning, if you receive the presentation, just click on the links and then you can access the information which is available there. This is the bioenergy of Falcon the website of Falcon Bioenergy, and it's located in Nevada. It's based on the plasma enhanced melter. This used to be rather interesting for me, the plasma gasification, and they are aiming about waste gasification, plasma gasification, about 90,000 tons, and the production of ethanol. Then I found the other project which is connected to the plasma gasification facility, and this is located in the riverbank, and it's also about the Inentec gasifier, who are doing the gasification and afterwards the conversion of the syngas. Another interesting consortium from my point of view is the Enerchem consortium, which are linked to them, or I don't know, and so they are doing the bubbling fluidized bed gasification. And in previous projects, I found that they had the air gasification, and this means no syngas production, and they are now shifting also to oxygen gasification. And this is one thing I would like to mention, which is maybe interesting in terms of the general overview about or the direction where the gasification is going, because now we have this is a rather new development that oxygen is available, because one main reason for developing the dual-fluidized bed gasification system was not to be depending on the oxygen and to introduce the energy within the reactor there. And now due the fuel cells or the electrolyzers where hydrogen is produced, the oxygen is in some cases a waste product. And if the oxygen is available, it makes sense again. And the funny thing is that VTD used to develop the oxygen-blown gasifier before, and then they shifted to the dual-fluidized bed, and then now it became already interesting. But these two approaches, I think, are rather interesting: the oxygen gasification, and of course the dual-fluidized bed gasification, which is on a rather high technology readiness level already. The Sherbrooke facility has been installed in 2003, but as you can see here on the operation hours, it's just 4,000 operations until 2022. And this means it's some of these facilities who are operated in campaigns. It's nothing wrong with that, but it's a difference to the developing a technology to be used for a commercial plant, like we aimed in Güssing to have a maximum number of operation hours, or if it's campaigns. The good thing is the feedstock variety that they are applying in the Sherbrooke plant, and the main products are cellulosic ethanol and methanol. Another Enerchem project is the Edmonton Waste to Biofuels project, and so the aim is also ethanol production and utilization of this municipal solid waste. This means waste gasification, and it's a rather large scale in Edmonton because they're aiming for 100,000 tons a year. Another major player I would like to mention is the GTI, the Gas Technology Institute. So they are active in this field for decades, and sometimes they are also including the most capable partners and rather huge consortium. So for me, it's some kind of like cooperating with ThyssenKrupp and so on, and so. The Velocis Fischer-Tropsch technology is one of the most advanced, and also using the Carbona gasifier from Andritz, I would like to say it's a most industrial application and very mature technology. And they have installed different plants. One of them is in the plants in USA, and they're using as feedstock wood chips, and they're producing fuels. So we have cooperations with most of these companies, but it must be clear that it's not an open innovation, it's a closed source technology. And there are different other developments ongoing at the moment. It's about the plasma gasification from advanced biofuel solutions, and they have installed the GreenTuesday bio SMG demonstrator. You can find this information, as I said before, when you click on the link there. And one rather large scale plant has been installed in Sweden, and what they are doing there is to utilize household waste for the gasification. So for me personally, it's also one of the most mentionable projects, also kind of lighthouse projects in this field. Another mentionable approach is Red Rock Biofuels. It's located in Lakeview, Oregon. It's also cooperation with Velocis, and using dry wood or forest residues in a significant amount. This means 127,000 tons a year, and the main goal there is to produce Fischer-Tropsch liquids. Another mentionable consortium is around the Thermachem Recovery International project, which is located in Durham, USA. It's still on a rather low technology readiness level, and the goal is to produce Fischer-Tropsch and mixed alcohols. Yeah, you can find additional plants there. I haven't included every plant and each of them, and most of all not them which has been shut down for many years, where the research activities has been closed. But if you would like to have a complete overview, then the work of IAA is rather good, and you can find all the information there. The same is with the research activities, so please click also in the link to get more information there. And one interesting presentation about bio-SMG, if you're interested into this topic, about the methanation application of the Syngas, then I would recommend this summary of the bio-SMG plants, where also some idea about the techno-economic assessment is included there, which is a rather hot topic at the moment, because I received some calls from our utility companies because they would like to avoid the same situation as it used to be in the field of anaerobic digestion some years before, where the feed-in tariff has been a little bit higher than the costs of the AD plant, and then, or let's say, the manufacturers has been optimized the systems and they installed rather large AD plants there, and for this reason, the people are now rather rather cautious about the height of the feed-in tariffs. And so this is also connected to the feed-in tariff in Austria at the moment, where the discussion is going on how much the feed-in tariff for the SMG should be on a larger scale, and which is not really the same scale and the same goal is the Biolic project, but I would recommend also to go into there, because it's a very good combination about the decentralized production, gasification, or pyrolysis renewable energy carriers with lower energy density, and then the centralized conversion into high quality products, and of course all the activities from NREL. Yeah, this used to be the second part of 3. This means the technologies and the interesting projects. Christian, do you have some additional information to any of these plans?
No, as you mentioned at the beginning, 2 important plants I think are missing. The one is the Gas plant, where the production of 20 megawatt of SNG from wood has been demonstrated, quite successful for some years. And the other one is the Wajima plant in Japan, an 8 megawatt fuel input, 2 megawatt electric output, combined heat and power plant, and was the first one in Japan which came into operation.
Yeah, I think this was an important missing information because these are also successful projects and defines the state of the art that we are facing now. So actually, the participants of this meeting have been involved in many of these projects. And so for this reason, I think it's good if we give an overview about the current state of the art. And my idea was also to refer to all the other projects which hopefully will come up, because if we are talking about 200 gasification plants already in Austria, then you can imagine how many gasification plants are feasible all over the world. So I've done some recent study in Nigeria some years before, and alone in one state there can be more gasification plants installed than in Austria, and there are more than 20 states in Nigeria. So for this reason, hopefully we will the other consortiums will succeed, that we will have more gasification plants soon. And the final part of my presentation, and this is also the bridge to our discussion, is the barriers. I've divided into 2 sections. One is the non-technical barriers. The other one are the technical barriers. And as we revealed before, I think one of the most or the hardest non-technical barriers are the security of planning for the products. So, yes, please, yeah. Sorry. I was just thinking somebody would like to mention something, and this is from my point of view, one of the most important things. This means to have some security for planning for, let's say, 5, 10, or 15 years for the products. For this reason, the feed-in tariff for the biomethane will be rather important, and also contracts with consumers of liquid biofuels. I think it's a good point in time now to start and to invest, because I think we have a stable situation, and conversion technologies have been decreased, even if the investment costs have been increasing during the past 2-3 years a lot. But I think the overall scenario looks good, and for this reason, I think there will be soon a few investors which will invest into this business. The thing that I mentioned at the beginning, which is also a non-technical barrier from my point of view, is that we would need more industrial plants. As we have seen during my presentations, there are some commercial units, but it's not like this that one manufacturer has been producing, let's say, 20 plants or 30 plants. So one of the most experienced partners is Christian Eichenig with Repotec, who has been involved into a series of plants. And so for this reason, we can say it's state of the art, but it's a difference if it's just 10 plants or if it's 100 plants. And for this reason, I think we need to come into the more direction. We know the situation from the boiler industry, where many of them are located also in Austria. And I think we have to come to the point there to have a real larger industry established. And yeah, the final non-technical barrier I've included yesterday is maybe some kind of provocative, but it's also you know, what I like is independent research institutes to name things, and so it's when I followed the legislations and the discussions about laws and about regulations during the past years, and it was crazy how many people are introducing their opinion into such processes. And and it's also like this, that you can't even estimate which party or interest group is voting for something. And if I have a look on the biomethane feed-in tariff discussion in Austria, some years before, it used to take, let's say, 1 or 2 years to finish all the negotiations, but they're still going on. And since 2 or 3 years, we are discussing that the feed-in tariff of biomethane will be decided soon, and there's still no progress because sometimes the industry is against it, afterwards the workers are against it, then the Chamber of Commerce is against it, then the left party is against it, and the right party is against it, and all these people who are crazy about just the lobbies are introducing their opinions. And from my point of view, the only way out is to provide transparent information, and this is also what I'm standing for, to provide transparent information about the technology itself and about the border conditions. This is the only thing how we can speed up, because otherwise we are stuck into the conflicts of interests, and in most of the cases the parties even don't know what the interests are. The technical barriers are smaller from my point of view, and yeah, I would like to say it's not even worth mentioning, because these are some small details we are resolving during development. And one of the most interesting parts is always about the feedstock definition. So this means the one thing is about the quality. There's always a discussion going on the interface between the supplier and the plant, the consumer itself, and it's also about the long-term availability of the quality. And for this reason, from my point of view, it's important at the beginning to sit down to define a worst-case scenario and to have a good collaboration between the suppliers and the consumers, because otherwise, if the war is starting, that one party is blaming the other, then you have lost already. So if the consumer the plant is blaming the supplier that the quality isn't sufficient, and vice versa, then this is a bad situation. So there should be put enough focus on the feedstock definition to have the negotiations, and it is also good because in this case you can talk about long-term contracts of the supplier, and I think this is also another reason to go into the biomass business, because if we watch the prices during the past years, electricity and natural gas, then everybody knows what happened. And there was, of course, also a price increase in biomass, but it wasn't that bad as in natural gas and electricity. Then the last 2 points are rather minor things. So the influence of the low quality fuels in the feeding system, the Syngas composition, it's more on the feeding system. And as you know, we've got a dual-fluidized bed gasifier. So this can accept nearly everything. So once it goes through the feeding system, then it can also be converted. Then the Syngas cleaning is also rather detailed, because we've got the PTX removal in the RME scrubber and so on. So for this reason, what comes out should be rather stable, and for this reason, that's not really a technical barrier. It should be put focus on it, but yeah, we know already sufficient, and we can still do a lot of research. That's not really a barrier. And the same is also about the long service life of the gas cleaning. So it's more a matter of the techno-economic assessment that we are still not 100% clear how much it is, but it's not really the huge cost, and for this reason I wouldn't say that's a real technical barrier. Yeah, as you see, maybe you can draw up some barriers afterwards if I missed something, but it was really hard to find out which barriers are existing. And so for this reason, I would like to come to the conclusion that the rollout is possible. So there are different initiatives going on at the moment in order to install a series of plants in Austria. And from my point of view, what we have done during the past to have some kind of open discussion. So it's sometimes open innovation isn't possible, but at least a cooperation between competitors is beneficial for everybody. And the other thing is the optimization about the entire value chain. From my point of view, this is one of the possible barriers, and this can be overcome with transparent information, because otherwise the feedstock supplier is afraid that the plant operator is getting rich, and if there's no transparent information, then also the consumer of the products, of the biomethane and the Fischer-Tropsch products, will be afraid that the plant operator is getting rich, and vice versa. So for this reason, if there will be a transparent information, and the other thing is the optimization about the value chain, because if such parameters are discussed openly, as we had before about the feedstock properties and so on, then everybody's in the same boat, and then entire value chain can be optimized. Right, this was it from my point of view for this first presentation, and now we are open to discussion. I will have a look now in the chat, which how many questions are there, and then we can start to discuss about details. Karina, I think there hasn't been any question in the chat, or what another?
No, not so far. So I didn't get the message.
Yeah, then let's start the discussion just with some just please raise your hand, and we will accept the speakers and the discussion partners just by the sequence of the where it appears to when you raise your hand. That's very good. If it starts slowly, because this means my presentation has been clear, or it has been completely unclear. There are just these two options. Yeah, thank you very much for the question. Maybe we can, in the meantime, talk about some organizational issues. So I've got this mailing list from the participants, and I also have some additional persons who couldn't attend, and they asked me also for the presentation. And both groups will receive the presentation, or the link to download the presentation afterwards, and also the link to the website, because we will upload the discussion and the presentation today onto YouTube, and there you can find the presentation. The other idea of today's discussion was also to discuss openly, so the idea was, if you meet somebody during the coffee break, and to exchange some information which is maybe not, this one you can find on all the newsletters, or some background information, or also some ideas, or even if somebody tells me that you don't believe that biomass gasification or gasification itself will be a promising technology. That's exactly the thing I would like to discuss now. Thank you very much, Günther. Please unmute yourself, because then we can start a discussion. So it was just about the sequence, how to place the questions there. That's a rather good point, because you also have got your energy or load line planning tool. So I think you are dealing for many years with load lines and also developing the software for it. The main trouble for the technology we are talking about are the investment costs. So it's, from my point of view, the same like with the fuel cells, where the investment costs are rather high, and it's the same that the specific investment costs are rather high, and this requires a rather high operation hours. And yeah, I think what we need to do is so if you're just introducing the heat from biomass, then technologies with smaller investment costs are maybe more feasible. Or what's also an option would be to shift between the thermal power. So, you know, the stories about power to X, and for instance, providing high temperature energy with electricity, which may make sense. So Christian and me also discussed sometimes introducing the energy into the thermal gasification via electricity. So this could be also some basis for load lines.
Thank you.
Maybe I want to add one sentence to this answer, Richard. The processes, the synthesis processes we are developing have an impressively high efficiency. Like, for example, the synthesis to SNG, as demonstrated at the GreenTuesday plant, has an efficiency of above 60%. So that means more than 60% of the energy of the wood ends in the energy of the final gas. And as a result of this, the remaining heat, or the by-produced heat, is not really huge. In the range only in this process, only in the range of maybe 20% or so. And that means even at a big plant like the GreenTuesday, it is only 5 or 6 megawatt. Still a lot to waste it. I agree, but does not have the same importance as for inefficient combined heat and power processes with an electric efficiency of 20%. Or lower sometimes, and heat output of 50 or 60% or even more.
But there are some interconnections with other technologies producing heat during summertime. If we change our heating systems to heat pumps, we can make sure that the peak electricity production in summer is used for the heat pumps. And if we substitute the heat pumps with the heat of the biomass, we enlarge the electricity excess in the summertime. Maybe it's lost, or we have to increase the power of electrolysis plants. I think it would be very good to take a look at whole concepts, not only concerning the biomass conversion. We have also to combine it with other technologies, photovoltaic, wind energy, and so on, and to make whole energy concepts. I was last year I was working in Murtal district, and there's a lot of heat success, heat in the summer. To integrate a new one means that we enlarge the heat access during summertime. So this is the reason why I came to my question.
Christian, also for the input, and thank you very much, Günther, for the summary. So that's exactly to the point. So both of you mentioned some technical details which still haven't been conveyed to politicians, and this is the reason why I'm really complaining about these things which are going on, because the only things which are going on is these things which are gaining the most of the profits. So now yeah. Photovoltaics is good, but the highest business is to have these huge plants on the free field, which is prohibited in countries like Italy, but in Austria it's still possible. And we are installing huge scale of PV plants because it's the highest profit. The next one is just about heating sector. We must move to somebody somewhere, and the politicians see oil is a huge amount. We need to move somewhere, and there's a good lobby about the heat pumps, and they have no collaboration with the other heating systems. And during the past, let's say 20 years in Austria, we developed solutions for everything within the research projects we had, and now we need just to implement them. And one very hard thing is to make consumers and politicians understand. But now I would like to move on because we've received the questions from Jan Stambaski, and Siegfried Kies would also like to say something. Maybe just a short answer to the last question of Kay Wucha. The disposal of the wastewater treatment plant sludge is a headache, right? And so yeah, I don't want to say it's a headache because it's already utilized somewhere, because it goes somewhere. For instance, in Vienna, we've got the huge municipal waste incineration, and it's more a question of profitability, because I know some companies who have developed solutions for thermal incineration. They may be higher, and then there's always the discussion going on about agricultural, because it should be prohibited. And this has been tested, and one of the plants is in Wien Simmering, where they are aiming for a mixture of sewage sludge, and the main difference between other fuels is the high ash content. We're talking about 50% of ash content. Then, but there are not really other limitations. One could be the ash melting point, which is usually fine in wastewater in sewage sludge, and the other one could be the heating value. And just please, yeah, is this answered sufficiently about this question? Yeah, if not, then we can discuss afterwards. And then I would like to, even if Siegfried Kies came later, I would like to know what the question is, Mr. Kies.
Okay, thank you. I think Jan Stambaski was right the next in the row for the question, and I just would like to add, or probably I can ask from my point of view. I think we saw that all the technologies are right advanced and right ready for takeoff. The problem is all about economics. And the question from my side to the audience would be: do you have any, let's say, major developments since the last 15 to 20 years, which show really a reduction of the costs, so that the product will be competitive, especially if we saw the prices, the volatility of the prices in the last couple of months or the last 2 years, then it should take off. But I can't get the feeling that it really happened. So there must be the hindering point. It's all about economics. And do you have a number roughly where all the technologies stands in respect to prices of the product?
Mm-hmm. Yeah, thank you. So this may be also some kind of to-do for our list, because one idea of our workshop or this kind of meeting was to draw up some to-do list for the future, and one could be to summarize or sum up the current situation in terms of economic situation. And thank you very much for the question, because so I don't need some kind of friendly issues. So we really must come to the point, and this is also what investors say, because they say, yeah, if it's profitable, why haven't been built there hundreds and thousands plants during the past years? And one information I can give you was a computation I've done some years before in one power to liquid project. I just have to note down that I will send you the link to the wind diesel project, and there we have included a rather detailed techno-economic assessment. And at this point in time, at the end of 2017, we found out that the production costs for 1 liter of Fischer-Tropsch diesel used to be around €1 per liter or even less. And so for this reason, I would say it's already profitable. Then there have been a lot of studies dealing with the comparison between anaerobic digestion and syngas production. And so depending on the price level of the feedstock and the assumptions, then the raw gas production costs of syngas has been between 50 and up to 80, 90 or 100 euro per megawatt hour, and at biogas it's starting above this price level. So I'm just talking about comparable figures. And if we are talking now about the technologies which can be implemented on a large scale, then prices are in this range that we will need for the bio-SNG, let's say 150 euro per megawatt hour. And this is connected to the price increase we faced during the past years. Happily, the THWin has been done a study during the previous time where they took into consideration the price increase, because it was really crazy. So it maybe Christian, you can also say something about it, that the investment costs have been increased during the past 3 years by 30 to 50%. So and this is based on inquiries we placed at the manufacturers. So this means if we have been talking about the price level for the bio-SNG in the past years of, let's say, 80, which would have been the minimum for the bio-SNG, then this is now 130 or 150.
Maybe Richard, I want to add 2 sentences here. The one is that as a general answer, I think it is difficult to directly compete with fossil energy sources as long as CO2 CO2 emissions have no price or have a ridiculously low price. At the same time, exactly this situation drove the world to the edge of a catastrophe. So I think it is evident and clear that we cannot go on with an economic situation where CO2 emissions have no price. If that comes into economy, I think this kind of projects will be feasible. But with the rules given now, they are not, at least not profitable enough. Under some good frame conditions, we can reach something like a black zero. That means they are equal to what is existing. But if we want somebody to invest into innovation with more risk maybe than conventional technologies, then we must show profits, not only a black zero as a number. And the second comment I wanted to give is that due to the fact that this kind of technology is quite complex, it has high investment cost, and that means that the capital has to be invested for quite a long period. So payback periods of between 15 and 20 years are reasonable for this kind of plants. This is not completely unusual, because it was the same for our conventional electricity systems, where also the existing power plants which we utilize today, also the hydropower plants, they had payback times of more than 20 years, and nobody was afraid. But in a situation which we face now, with high volatile prices for the energy products, this is a huge risk for investors, and that is also one of the barriers we have to face, I think.
Mm-hmm. Yeah, Hermann, but I can also ask Alexander Bartik or somebody, or Martin Hammerschmidt for the study, because I would like to refer to the study where you have shown that the latest figures about techno-economic assessment.
Yes, we have done it, yeah. But before, I want to mention that we have also made a study 3 years ago for the government, for the Ministry of Agriculture, and we showed that it is possible to produce the diesel for the tractors and for the trucks with the residues from the biomass, from the agriculture and forestry. And also here we tried to get figures for the costs. It was before the crisis, I have to say, and there we came to the conclusion that it is competitive to the fossil parts. So we came to prices for the diesel for €1.20 more or less, something like this. It is a mean price. We made some, of course, different approaches, different fuels, different sizes of the plant. You also mentioned that the larger the size, the cheaper the price for the liter of the fuel. So we found out that it would be competitive more or less with the fossil fuel. And Christian also mentioned, if we take into account that we have a price for the CO2 emissions for the fossil, and yes, then it would be more or less competitive, as I already said. This study you can get if you write me an email. I can send it to you. You can see the figures. And what Richard says, some colleagues of mine made a study what changes the last 2 years with this figures for the costs. This volatile changes over several months for the electricity or for the prices of the energy. You can see also the numbers they get out there. You can also get this publication if you send me an email. I can send it to you, or even Richard can do it if you send it an email, and we can give you this information.
Thank you very much, Herman. So I will gladly include this information. And yeah, so I had it in mind before to talk about the study you mentioned about the real lab in Austria. And I think it's rather trend setting. As you said, it has been established for the Ministry of Agriculture. And the result was that you just need 9 plants in Austria in order to decarbonize the entire agricultural sector. This means no CO2 emissions more from any tractors or any machines there. And I think this has been rather trend setting. I'm just afraid it's just available in German, or isn't it?
Sorry?
It's just available in German and not in English.
It's just in German, but there are some publications taken out of the figures also in English. So, but the study, you are right, it is in German, yeah.
Yeah, so don't worry. There are sufficient people are native Austrians in the mailing list, and for them it will be rather interesting. And for the others, we will just add the papers. Your colleagues have been established. So one of them is rather recent, and it took into consideration the price increase during the crisis. And so yeah, it's crazy how investment costs have been increasing and how unstable our system is at the moment. Yeah. So, Mr. Kiss, is it fine for a general answer to the costs?
Sure. For sure, we know all these circumstances. I just wanted to get probably a new point of view on the new overview, because what Mr. Hofbauer also mentioned is, yes, there's the price 1.50 euros per liter or something like that. You have to add the tax to this product, and then because that's for the Ministry of Finance is very, let's say, necessary for the budget, real world budget. So, and this was the same for years, 20 years. And I have the feeling there must be something else behind the scene that all the technologies really don't take off. That's just my personal view, my personal impression, what is going on. Because if you have readiness level of 9 and above, and no investments are taken, across the globe, I don't have an answer for that.
Yeah, just I also don't have any answer on that. I just have a feeling, and the feeling is that we are too honest and working too hard and not doing sufficient marketing and not lobbying. Because so if you watch the developments behind the e-fuels, so I think e-fuels it's fine, and I don't want to complain because it's in the same area as we are, and so also they have achieved a lot, to make the people understand that there are synthetic fuels and so on. But there are also some other developments which is connected to the thing you said before. We don't have this lobby in the field, so it's a shame that I know nearly every person personally in this field, because this should be an industry with, let's say, 100,000 people engaged in all over Europe. So because if we're talking about 200 plants in Austria and all over the world, then there should be a rather huge industry established. And from my point of view, the trouble was that we used to be working too hard in order to resolve everything. So same as Günther said before, we've got the solution and the best models, and we can determine the best system. But it's now about connecting everything. So this is the reason why I don't want to complain about the e-fuels, because they're also doing something in the field, but there need to be more cooperation, and also between PV and wind. So because it's sometimes also a competition. I think that's human. I know that we always thinking about problems and competition and this kind of things. But from my point of view, what we would need really is now to have some kind of lobbying. And then we just need to use the existing figures. So I also have the same feeling, because there's so much moved if the lobby is behind. So if you think about the electromobility, when they started 15 or 20 years before, and where they are now, or if you're thinking about the heat pumps, because we discussed it before, there's also they have some interest groups and also some lobby which is behind. And it's the same now with the e-fuels, and even larger maybe the hydrogen, where there's a lobby behind. And maybe our technology is not spectacular enough. It's one of the cheapest. So if you made the techno-economic assessments, and maybe it's not too as sexy enough. So,
I'm just wondering, the last decades already, because we would be ready to store the gas or SNG or biomethane for providing the flexibility to the market or to the customers, and we can't see that there is an increase really foreseeable.
Yeah.
Although the price situation has changed dramatically in the last 2 years. So I have no idea. Thanks a lot.
Yeah, thank you. So I will ask Bernhard Pelzel soon. I just would like to add something about, because it fits rather good to a discussion we had the last time. So maybe it's really about, because it's not really sexy enough our solution. When we think about the Dual-Gas project, one of the main reasons why they stopped it afterwards, because there was no consumption of the bio-SNG. It was a rather good idea at the beginning, that they said we have these CNG vehicles, and it's an available solution to be 100% carbon neutral, or nearly 100% carbon neutral in terms of mobility rather soon, much faster than with electric cars. And then consumers haven't been very interested in order to go for CNG vehicles, and the emissions of these has been low. So this is what I said. It's not always the best technical solution which is then selected, and maybe our mistake was that we've been developing our technologies by ourselves and not by marketing and lobbying colleagues. So then I would like to ask Bernhard Pelzel now, and afterwards Günther Wind.
Only some thoughts. If we would build a lot of plants, then the availability of these fuels would be higher, so the price would get lower. I would expect this as also a part of the calculation. And the second thing is, who are we competing with? I had I think 10 years ago, an interesting conference about artificial photosynthesis with the NOVA Institute. They are also promoting this alternative energy and artificial fuel production. I don't know how successful they are, but they had involved all the German automobile producers like BMW and Volkswagen and so on. And I think it's a fact that not the best solution, the technically best solution is the one who will compete in the end. But as you said, the best explained solution or the best offered solution.
Yeah, it's rather clear. Yeah? Thank you. Günther?
Yes, you said we have no lobby work for our technologies, for biomass technologies. And if we consider a biomass technology is the only technology that has costs for the feedstock. Sun, water, and wind power, they have no feedstock costs. And if we have an inflation, we have to pay more for the manpower. So our feedstock gets more expensive. And our lobby communities are the biomass associations and biogas and so on, but I never heard something for energy taxes. Energy taxes are discussed, CO2 taxes, we have a small one, but from our biomass association never gets a pressure to the politicians to make lobby for energy taxes and to stabilize an energy price with CO2 taxes or energy taxes or so on. And this is a problem. I'm wondering about the biomass in good connection with the ÖVP, but from the ÖVP they are against such taxes, and this I'm wondering about it.
Perfect, Günther. So I think it's a very good argument. Would like to answer somebody else than me, or should I?
Yeah.
You know, I just want to avoid this monologue that I'm answering everything and so on. Just would like to moderate the discussion. So for this reason, if somebody else would like to step into this discussion, then I don't want to hinder them.
But you will have a good conclusion and answer.
Yeah, very good. So that's good that Peter is here. So in advance, before Peter can answer, I would like to add something before, because when I've been talking about we have no lobby, and it was exactly as what Günther said, that of course we've got the lobby, and the Austrian Biomass Association is very good in Austria, and they are doing a lot. It's the same with biogas. So my comment should have meant so. It's still not enough, because this e-mobility and hydrogen and these lobbies are too much. So sorry that the Biomass Association is doing a perfect job. I think it's one of the best in Europe. So just in advance, before Peter Lipta from the Austrian Biomass Association can continue.
Yes, thank you, Richard. Yes, it's the topic of the CO2 tax is one that we as a biomass association, we are asking for that since our beginnings. This association almost exists since 30 years now, and we always had the wish to implement a CO2 tax to make the fossil fuels more expensive. But last year, the fossil fuels became much more expensive without the CO2 tax, just because of the crisis, the energy crisis. And then Austria had to spend 20 billion euros just for the imports of insecure gas and oil and coal. So, yeah, regarding the connections with politics, it's true that our sector comes from the agriculture, and of course there is a connection somehow to the government, but there are also other interests, of course, from the economy. There is the big economy who doesn't want a CO2 tax, or not a high CO2 tax, because fossil oil and gas is still very big in Austria, and that's why it's also difficult for us to get our points implemented. It's not that easy, even if we have connections to the ministry, but still there are big other players who are still favoring fossil fuels, oil and gas. So we don't have that, and we don't have an easy stand, even if we do a lot of lobbying.
Yes, of course, and the other issue which fits to the discussion now is that it was crazy when they discussed about that biomass is no renewable energy anymore. So that yeah.
Yes, that too. That was another part of our work. We had a lot to do, especially our Christoph Femeter, our Secretary General, and also the presidents of the Biomass Association. It's good that we have, in that case, good connections to the EU. The people from Austria in the EU, like Simone Schmidbauer and Alexander Bernhuber, they did really a good job to make sure that bioenergy still remains a renewable energy source. But was not sure. It was really very fragile. The discussions on the European Union was very difficult, and really Austria has done a lot to make sure that bioenergy is still a renewable energy source at the moment. Yeah, it's not very easy on the European Union level.
Mm-hmm. Mm-hmm. Yeah, so as I said, this is an open discussion, so just please feel free to add something, and then I will just, until you make up your mind what you would like to say next, then I would like to apologize for Jan, because you've been asking before, and now it's nearly half an hour later or more than that. Right, so the business cases of the plant have been always on the border of profitability. So I will send afterwards the link to the wind diesel. I need to apologize, also just available in German, but where we said it's possible to produce the diesel around 1 liter, and so now, since the prices have been changing, they should be profitable. But the trouble was always that the other energy was too cheap, because if we're talking about the natural gas, which is about, I don't have to tell you, about 20 euro per megawatt hour, and the biomass is the same, then that's not really working. And in terms of the business cases from these dual-fluidized bed gasification plants compared to the other technologies I mentioned, or the demonstration process or references from the other manufacturers, it's still the most profitable, with the lowest investment costs and the lowest operation costs. Does this answer your question? I think you're still muted, Jan.
Oh yeah, perfectly. Thanks. That was great.
Perfect. Right, then from Christoph Rief, to answer this question, I think so I can show to you what I would like to share afterwards. So when I'm sending my minutes, the biomass and power to liquid has been a project we've been working on some years before. It's already closed for some years, and this was the reason why we went into this direction, because the difference between these two processes is just the installation of the additional equipment, the electrolyzer, and to have the downstream units a little bit larger. So because this is the standard biomass to liquid process, where the biomass goes into the gasifier, then we've got the standard gas cleaning and the fine or high efficiency gas cleaning, and then we've got a Syngas ratio of 2:1, which is required for the Fischer-Tropsch synthesis. And this goes into the Fischer-Tropsch process and the separation. And if we now talking about the combination of a biomass to liquid process and power to liquid, then from my point of view, that makes a lot of sense, because we also have investigating some load lines. This means when renewable energy is available, let's say 2,000-3,000 hours a year, that we can use this electrical energy in order to introduce the hydrogen. And this has been developed by Wien and their partners, that they have the option to change the Syngas ratio, and then the hydrogen is introduced. And with such, we can couple a 50 megawatt gasification plant to a 33 megawatt electrolyzer. And the additional investment is just about the electrolyzer and make the downstream units a little bit larger, the 70% more product in the downstream process.
Okay, thank you very much for the explanation.
Yeah, so and this is also what is connected to the things we discussed before. Maybe it's too logical and too good, that there's not really a high interest in it. And so one of the main reasons why we developed the project and published it was also to make it publicly available. So because it should be also some kind of technology which should be implemented. And as you know, the development is always the hardest in the details. And we had some cooperations also with AVL and also with VTT, and it's always about the details. For this reason, I'm also aiming for some kind of capacity building and know-how exchange between people who are active in the field. Which energy projects you mentioned, Günther?
At the beginning of your report, you mentioned the heat pipe reformer from Germany, I think it was. Is this technology in use now, or and what are the chances in the future for this technology?
Now you placed the question which I can't answer in detail, because I don't know the latest developments. Hermann and Christian, have you heard about the latest things? It used to be a very good scientific accompanied project, but then I don't know if Agnion went bankrupt sometimes or something, and then they haven't started again. So do you know more details how it continued, the Agnion concept? It seems no. So I know that Dr. Herdin has been there, who is used to be a very good expert in the field of.
It's a similar history as other plants had, so to say. They met a demonstration plant in Germany. It was in operation for several years, I would say, but then it was closed down. And so I think there are no further plants now in planning or in erection there. So.
Thank you.
Yeah, maybe one disadvantage for the Agnion system may be that the oxygen is available that cheap at the moment, and so could be, yeah. But yeah, I also haven't heard something. I also haven't been in contact with Professor Karl, who has been involved rather good into this project. So sorry, so no further details on the Agnion process.
The advantage to use pure oxygen instead of air is that you have no nitrogen in the
Exactly.
Exactly.
Okay. So you can produce the Syngas. This means this is some autothermal gasification, because the energy is introduced via partial oxidation of the Syngas, And this is the difference to the allothermal, where we have the circulating fluidized bed material. And due to the high amount of gasification agent, the nitrogen content is usually 50% if air-blown gasifier is used. And this is hard in the downstream process to be removed for the natural gas. It's rather hard, and it's the same also for Fischer-Tropsch.
But in all fluid gasification as we are doing, and also in heat pipe reforming, they have also no nitrogen in the product gas, but it is more complex, of course, yeah, because we have a separated heat combustion chamber, and we are only heating the bed material and bringing it back to the gasifier. So we need no oxygen and have also no nitrogen in the product gas. However, if you have oxygen, then you have not a dual fluidized bed gasifier, but then only a single bed gasifier. This is the advantage, maybe, if you have oxygen available.
Nice ringtone. Yeah, it was also a very interesting information from Peter Litter about the amount of money we are spending for these net imports of renewable of this energy. And if we know now that until 2045 we can increase our share of renewables by at least 20% of the total energy consumption, I think that's a lot. And it's it's always the details. So as we said, it's about optimizing the system along the value chain, then to have the reliable suppliers. And for this reason, they're going some projects on now in order to optimize the feedstock availability and this kind of stuff. And so it's also about the quality of the fuels. I think this is fine, but we need to do some final tests and this kind of things in order to have this drop-in fuels implemented on the market, and then we can decarbonize our system rather fast. And it's also needed, because if you're shifting everything to electromobility and these kind of things, many machines will remain as they are. And we discussed also, especially in agriculture, due to the seasonal work, it's not possible to have them powered all by electromobility and these kind of things. Are there any additional ideas? Because I also said I can do a follow-up. So as I already said before, we will send you the presentation and also the records, and also then the studies. So do you need some additional information, or would you like to add something to our discussion now? Yeah. If not, then that's rather good, because we just exceeded our time frame by 8 minutes, because we had the idea to have it a compact format for 1.5 hours. And this is not the end of the rainbow. If you would like to need something, then just please send me an email, and then I will connect you to the most suitable expert in the field. And this means we can answer all your questions afterwards. And if you have some ideas for additional actions, then just please let me know. We can arrange another Green Tuesdays on a different topic. Or if you have any input or ideas, just reply to my email, and let me know if you need something or have some ideas. Yeah, so it was a pleasure for me to have the discussion, and I'm looking forward to any further events or for some personal meetings. So thank you very much for your participation, and have a nice day.
Ciao. Thank you.
Thank you. Bye.
Thank you. Bye. Thank you. Bye-bye.